This is problem 8-138 from section 8.3.2. Carlos is trying to factor the polynomial p of x equals x to the fourth minus 4x to the third minus 4x squared plus 24x minus 9 to find all of its roots. He had already found one factor by making a guess and dividing the polynomial. So he had p of x equals x minus 3 times x to the third minus x squared minus 7x plus 3. So this is the factor that he found, that he guessed, and divided by. He was trying to factor the other part, so we tried dividing it by 3, or positive 3, and then negative 1 and positive 1, but none worked without a remainder. Then Tio came by and said you should look at the graph. How does the graph help? If I look at the graph, I can see where my roots are. There's one here, another one, and then it bounces right here. And that part is going to be at positive 3. So its factored version would be x minus 3. And since it bounces, I know it's squared. Okay, so since the third, or the root at positive 3 bounces, I'm going to divide by x minus 3 a second time. Not just this first time, but I'm going to take this cubic and divide it by x minus 3 again to get it simpler. So I'm going to draw a rectangle here and just write what was left over from the first time. He had x to the third minus x squared. If this messes you up to have it on the bottom, you don't have to write it on the bottom. You can write it to the side or just look at the problem again. So we're going to divide by x minus 3 a second time because the root bounces. It's a double root right here. Okay, so because that bounces, I'm going to divide by that same factor again. So to do my polynomial division, I know in this first box should be my leading term of the cubic, so x to the third. So x times x squared would give me x to the third. Alright, now I know x squared, so I'm going to multiply x squared times negative 3 x squared. Okay. So my next column, I'm just kind of making rows as I go rather than knowing how many I need to do. Okay. So my next thing needs to add up right here. These two need to add to be negative x squared. So I'm going to have this be a positive 2x squared in order to make that happen. Okay, so to figure out what times x gives me 2x squared, it will be a 2 and an x. Now I multiply the top 2x times this negative 3 to give me negative 6x. Okay. Next I know these diagonals are going to have to give me a negative 7x, so I need another negative x in here. So that x times what gives me negative x, negative 1, and negative 1 times negative 3 gives me positive 3, which was supposed to be here. So that means it is a factor since there is no remainder. So what I'm going to write everything that I multiplied together to get the original x to the fourth term. So I had x minus 3, and I had that twice, right? I divided by it twice. One time they did that in the problem before, and then we just did it the second time. And what we have remaining is the top of our rectangle. So I have x squared plus 2x minus 1. And I'm trying to find all of the different roots, and I know there was 3. I can see from the graph that one should be at positive 3. And so when I set each of these parentheses equal to 0 and solve, I'm going to get x equals positive 3 as one of my roots for this one. It would be a double root. We'll write that it's a double, where it bounces. Now I need to solve this quadratic equation. And what I could do is possibly factor it, or most likely I'm going to have to use the quadratic formula. So I'm just going to start with that anyway, because normally, as I can see, it's not nice numbers, right? They're kind of in between the spaces. So it would have to factor if they were nice numbers. So I know this is probably not going to factor. So opposite of b plus or minus the square root of b squared minus 4 times a times c divided by 2a. Alright, so let's see what we get here. X equals negative 2 plus or minus the square root. This is going to become 4 plus 4, so that would be square root of 8 divided by 2. And I want to reduce this radical 8, so I could say, well, that's really the square root of 4 times 2. I know the square root of 4 is worth 2, so I'm going to pull that out of the radical and have that come in front now. So this number is from the square root of 4. and I'm going to leave behind the square root of 2. And that was all divided by 2. So I'm going to simplify this so I can cancel all these 2's out. So all I have left is negative 1 plus or minus the square root of 2. Okay. So that's 2 of my roots right here, and I had a double root right here, so that's why it was originally an x to the 4th equation, and that's how I found my roots.